All right, you guys, I wanted to make a video of the calculation for correlation just so you guys could refer back in case you get stuck while you're at home doing your homework. All right, so correlation, we should know that it is a measure of the linear association between pairs of values. So correlation only talks about how strong that straight line relationship actually is. Okay, when we actually do the calculation, we first have to find the mean and standard deviation for both x and y. We use s of x and s of y to remind ourselves that there are two standard deviations, one for the values of x and the other for the values of y. Okay, we use the means and standard deviations to find the standard scores. We usually call those the z-scores for each x and y value. So by converting to the z-scores, what we're doing is we're essentially eliminating all of our original units, and we're using a z-score, which tells us how many standard deviations we are above or below the mean. So we're really stripping away the units by only looking at the z-scores. Again, how many standard deviations above or below the mean each piece of data falls. Okay, in step three, we end up averaging the product of these standard scores. Okay, and our process for averaging is really similar to the sample standard deviation. We average by dividing by n minus 1. So one less than our total amount of data. So if I write my formula in a more user-friendly way, I would write it as R equals that big uppercase sigma, which just means sum of zx times zy. So we're looking at the sum of the z-score products, and then we're dividing that by one less than our total amount of data. So that is the calculation that we're going to actually build towards at the bottom of this sheet. Okay, when I look at this visual right here, I'm just giving you an example. Foot length on the x-axis, the explanatory variable, and we want to see if it influences the height of an individual. So when I'm looking at this graphic, what's important right here is this location. So these two lines are my mean lines. So right here, this vertical one represents the average of foot length, whatever my x values are. And this one right here would be the average of my y values, which is overall height. So right here where they cross, that is a point of averages. So I can think of it as x bar and y bar because it's the average of my x values and the average of my y values. So then over here, look at my visual. My visual looks pretty much the same, right? The scatter plot looks the same, but what's different is now we're looking at the z-score for foot length and the z-score for height. So we've converted all of the raw data into its z-score equivalent. So right here, this location, that point of averages that we saw right here, when I think of an average in terms of a z-score, let's say that the average height is 70 inches and I'm 70 inches tall, as a z-score that would show up as 0. So z-score of 0 means that you are the same as whatever the average is that you're looking at. So right here, this point is our new origin 0, 0. And each of these points, instead of just being x with y, this is now z of x, z of y. So again, all of our raw data just got converted to a z-score equivalent. So if I picture this as just a coordinate plane and I'm looking at my quadrants, over here in that first quadrant, I would be pairing a positive with a positive. Here would be a negative positive. Here would be negative, negative, and here would be positive, negative. So the reason those signs are important are when I look at my formula, I'm going to have to multiply the z of x and the z of y. So this point, for example, I'm multiplying something positive with something positive. Its product will be something positive. anything in here will produce a product that is positive. Anything here and here will produce a product that is negative. All right, so now let's actually walk through one example. So here we have a marketing manager conducted a study to determine whether there is a linear relationship between money spent on advertising in thousands of dollars and company sales also in thousands of dollars. The data are listed in the table. So first I just want to think, do I assume that advertising expenses is explanatory or response? Which one influences the other? Does advertising expenses influence company sales or vice versa? And I would say the way that I said it makes sense, right? Money that we spend advertising, we're interested in how does that influence our overall company sales? So that means that if advertising is explanatory, I'm going to type that data into my L1 and then show that on my x-axis that this is advertising expenses. And then the y-axis is my response variable, so that will be my sales right here. Okay, we know that both are in thousands of dollars. And then I just have to give it a title, so I'm just adding my context. So here we're looking at, does money spent on advertising influence company sales? So I could write that as a question, right? Or I could just write a sentence or a statement. That's fine. I'm going to write it as a question. Does the money spent on advertising influence company sales? Okay, so I have my frame built. We should have our data typed into the calculator. So you might want to pause me for a second because I have my data typed in. So if you still need to type yours in, then just put a little pause right now, type it in, and then unpause. All right, so here we go. Here's my data. I want to make sure that I take the time to check it. So I'm just making sure that everything is paired up the way that it's supposed to. So again, I have to make sure that this X value pairs with this Y value. So I'm just checking, I'm skimming through just to double check that everything lines up. And once I feel good, I'm just going to go home. So I'm back in my home screen right now. I want to make sure that my scatter plots are ready. So I want to go second Y equals. So if I look in my stat plots, I really only want one of them on. I want that first one on. And I want it to be on scatter plot. So it should be on. It should be on this type scatter plot, my X list L1, my Y list L2. So in our case, we're looking at advertising expenses and then company sales. You pick whatever mark you want. Okay, I'm going to go home. I think that I'm ready. One other thing that I usually do also is just double check my function list. I don't see any functions in there. We have not typed in any yet, so I'm just double checking that is clean. So we look good. So I'm going to go back home, and now I'm going to do zoom 9. So zoom 9, and then it shows my scatter plot. Okay, I don't have to tweak my window at all. I can leave it as is. So I'm going to pull my calc away and redraw it. Okay, so here's my graph of the data. So again, each point represents the amount spent in advertising, that's the X, and the Y is the company's sales. So each point, right, is represented as an ordered pair. All right, so now I need to decide, does it look like there is a linear association? Yes. I can see a straight line emerging, especially with these points. These ones deviate just a slight bit, but I can see a positive trend emerging. So I would say that it looks positive, strong, and linear. All right, so the first thing that I need to look for is, does it look like there is a relationship between the data, and is it linear? And I would say yes, right? I can see a positive straight line relationship. Positive because the slope of that line would be positive. All right, so now I need to calculate the correlation. So remember that those two words, they're often used interchangeably, but they really mean different things. So association is just broad general. Do we see a pattern in our data? And then correlation is how strong specifically is that straight line relationship, right? It's quantifiable when we talk about the correlation. So that's what we're calculating now. Let me zoom in a little bit tighter. Oh, other way. All right, so here we go. So in order to calculate the correlation, let me remind you of my formula. And the formula I will provide you with on a quiz. I don't need you to memorize it, but I do need you to know how it works. So I'm looking at the sum of the products of the z-scored for x and y, and then I'm taking the average, almost average, right? Because we're dividing by one less than our total amount of data. And in this problem, we have 8 pieces of data, so our end value is 8. So let me write that right there. All right, this chart, I don't need you to use the chart as is. What I'm trying to have you do is just remind you of the steps in your calculator. So you don't have to write down everything that goes in every cell. It's just meant as a guide to help you type in everything into the calculator correctly. So what we're going to need is all of our raw data in the L1, right? That's our advertising expenses. I'm going to move in just a moment all of the company sales here into the L3. But before I do that, I need to calculate the mean of advertising expenses, and so mean and standard deviation, and then mean and standard deviation of company sales as well. So let's take on the advertising expenses first. So advertising expenses in my calculator, that's in the L1. So to get to the mean and the standard deviation, I'm going to hit Stat, go over to Calc, 1 variable statistics. So I'm hitting Enter right there. And I need to tell it where my data is. And my data is right now in the L1. So second 1, and right there it gives me the average of the X values. And the sample standard deviation is right here. So my average for advertising is 1.98 and its standard deviation is 0.42. So I'm just taking it to 2 decimal spots. Okay, so that is the mean and standard deviation for advertising expenses. And I need to do the same thing for company sales. And again, they're both in thousands of dollars. All right, I'm going to clear. Let me get it into a place where you can see my screen better. So right there looks good. So I'm going to do the same thing. I'm going to hit Stat, Calc, 1 var stats, 1 variable statistics. But I have to tell it where my company sale data is, and it's in my L2. So I need to hit second 2 right here, hit Enter, and it's going to give me my average. So that X bar is going to be the average. And I had it look at the L2, so 204.25. And the sample standard deviation is 23.34. So I'm just having you round to the nearest hundredth. Okay, let me pull that away. So I know the average of my L1 and the average of my L2. So advertising expenses, company sales. All right, so now when I go to my calculator, what I need to do is I need to standardize. So here's all my raw data for advertising, and I want to convert to a z-score. So z of x, and then here I'm just reminding you of how you do that. So you're taking your observation minus the mean dividing by the standard deviation. And then over here, we're going to do the same thing, but for the y values. So I want to convert to the z-score for all my y values. So each observation minus its mean divided by the standard deviation. Okay, so let me put my calculator back here. So just for my own preference, I like to move the data that I had in the L2 into the L3. So let me show you how to do that. So I'm in my lists. I'm just going to go up and over to where L3 is right here. And I want to say L2. I just want to copy L2 over. So I'm up there nice and black. I want to hit second 2. So second 2. And I see L2 shows up. And when I hit enter, it's just going to copy that list over into the L3. So I want to go over here to the L2 and just clear that list. I want everything in my calculator to look like what's on this sheet right now. So if I just scroll over, I just want my L4 and L5 to be totally blank. So right now, I'm good. I'm looking pretty good. So now in the L2 right here, I want to convert all of my advertising expense here. I want to convert it into its z-score. So up at the top right here, nice and black, I'm going to open parentheses because I want my numerator to be treated as a package. Okay, and all of my observations, all of my data are in the L1. So I'm going to hit second 1, L1 minus the mean. I'm going to build off of this rounded answer right now. I'll show you how to do it more precisely later. So my mean is 1.98, closing my parentheses. So observations minus the mean, right? Data minus the mean. And then I'm going to divide by the standard deviation of 0.42. Okay, so observation minus the mean divided by the standard deviation. When I hit enter, this whole column fills up in my calculator. All it's doing is it's taking my advertising expenses and it's converting to the z-score equivalent. So I'm just going to transfer the first 3 numbers. So I see a 1, a negative 0.9, and a 0.05. Okay, so again, I'm just transferring those so you can be sure that we match. Okay, in my L3 here, I have all of my raw data for company sales, and I want to convert here in my L4 to its z-score equivalent. Let me move my calculator one more time. All right, let's see. I want you to see it all. Okay, so right there. So here all of my raw data is in the L3. In the L4, I want to convert to the z-score equivalent. So here I want to go up to the top. So here I'm at the L4. I'm going to open my parentheses. So I'm just typing in open parenthesis. And I want to say, look at all of that data that's in the L3. So second 3. Okay, take away the mean. The mean is 204.25. I'm going to close my parentheses. Again, I'm just trying to preserve my order of operations. So observation minus the mean, and then divide by the standard deviation. So 23.34. So that column fills up. So right here I have 0.89, negative 0.87, 0.67. Okay, let me pull my calculator away for a moment. So now what I have, right, I have all of my advertising expenses, and now the z-score equivalent, all of my company sales, and then the z-score equivalent. So now over here in the L5, I want to multiply these 2 columns. And I know that I'm paying attention to the sign, right? Because if I go back to this visual, just slide for a moment, right here, I know that if I multiply anything in these 2 regions, that will produce something positive as a product. Anything in these 2 regions will give me something negative as a product. All right, let me slide back up. So now in the L5, we need to multiply the L2 by the L4. All right, so if I slide over, here I'm in the L5. So I need to say, look at L2, look at all those z-scores for the x values. and multiplied by the L4, look at all those z-scores for the y values. So this column fills up. This one would be about 0.89, about 0.78, about 0.03, and so forth. But again, if I look through, I see a whole bunch of positive products. I really only see the one negative right here, and then I'm back to another positive one. So it makes sense that my correlation, if I'm looking at a visual that is a strong linear relationship with a positive slope, right, then I expect my R value to be within maybe 0.8 and 0.95, somewhere in that realm if I was just estimating. All right, so now I need to find the sum of my L5. All right, so I need the sum, right? That's exactly what this is going to be. The sum of the products of the z of x and the z of y. So let me go home. Okay, so I'm back at my home screen. Okay, I need to find the sum. So I hit second stat, over to math. I want that fifth choice, right? I want the sum of the L5. So second 5. So it's going to give me the sum of the L5. So that gets me about 6.39. And then in terms of work, I'm really just looking for this paper trail to the right. So R will be about 6.39, right? Because I'm rounding, right? That wasn't exact. I'm seeing it more precise over here in my calculator. I'm going to divide that by 1 less than my total amount of data. So I have 8 pieces of data. I'm going to divide it by 7. And I get a correlation of about 0.91. So remember, the closer we get to a positive 1, the closer it would be to a perfectly straight line. So we're showing that this is a very strong relationship between the variables. Okay, so if I go back up and I remind you of that visual right there, right, we know that if it was an R value of 1, all of the points would have been on a perfectly straight line. And the closer we get to positive 1, right, the closer we'll see that straight line with a positive slope. All right, I hope that was helpful, just seeing how we get to the correlation. Have a good rest of your day.